Alright, we're moving on to segment 8 of Adventures in the Library. Last segment, we had some problems where the formulas I was drawing out on the clipboard didn't show up. So now there is a new feature every time we do some drawings or diagrams. They're going to be on, not this, the clipboard. I'm going to do them here, but you will see the drawings and diagrams in a supplement to the segment. So basically, last segment was segment 7. There is a segment 7A that explains the structure and does a lot of the diagrams on a whiteboard that we did on here, so you can go and see that. So we're now going from 7 to 8. So we're on segment 8 here. We've more or less filled up our chart, and what you'll see on the segment 7A is that we covered the structured butane. And if you look at the structured butane, we've got in the center here, we've got because butane is number 4, we've got 4 carbons, and when we write this out, what we notice is that there are 2 carbons in the center that are bonded on either side by other carbons, and so they only have 2 free bonding spots to accept hydrogen. So these 2 become CH2, where the carbon on the either ends of the chain have room for 3 hydrogens, and they are CH3. So what happens is that we see that the unbonded carbon, the single carbon hydrocarbon as CH4, only exists for that one methane, that one situation of methane. When you start moving up the chain into more and more carbons, you're going to have at the ends of the hydrocarbon chain, you're going to have at either end or both ends, you're going to have the CH3s, and then in the middle you're going to have the CH2s. So that's the fundamental structure for these hydrocarbons at this particular point in time. We've filled up an entire sheet, so what we're going to do is we're going to go back into the book. We're going to continue on with Adventures in the Library on organic chemistry. We're going to title our page Adventures in the Library. This is so that if we use it, we're taking other notes for other things, we can know what and where we are. Right, and this is the second page. Okay, so now we put this down and pick up our encyclopedia here, and we go back to organic chemistry. Nucleic acids. And I think what we forgot to do last time is we forgot to put a bookmark there, and so we're going to do that now. There we go, organic chemistry. We have to go to the beginning of organic chemistry. And we will get something from our bag of bookmarks. It's an ace. This is from our bag of bookmarks. And as we see here, if we look up and see here, we have, actually they have here in the list here, they have they have 132 from 1 to 132 different hydrocarbons that are on the alkane. So the alkane is the single bond, and all the endings will have the like methane, ethane, propane, butane. And then what happens is once you get above 4 and into 5, you get pentane, hexane, heptane, octane, nonane, decane, right? Is undecane, dodecane, tridecane, tetradecane. And what we see is this is the Greek way of counting, right? Basically, instead of decane, it would be deca, right? Then you have endeca, dodeca, triadeca, deca, tessera, deca, pentadeca, and all the way up again throughout the whole thing here. And then in other words, most of the hydrocarbon chains follow the alkanes follow the basically they're named after numbers. So it's not uncommon to see, a number type of thing of alkane, or any of the other ones. Because what happens is they change the ending ane to ene, and there's a whole bunch of other endings as you will see as we'll get into this. But the one we do know there's one we actually know very well in the alkanes, and that's octane. Octane is our gasoline. And what we can do is that we can go into this further and look at the different properties of things. The ones we want to take a look at is we're going to come back to it. We're not going to do it right now. We're going to come back to it. We're going to because we're more or less done for the moment right now. We're more or less done with the organic chemistry. We see the organic, and then we see we have. If we look at it, once you go beyond 2, there are options in how you bond the carbon chain together. You can do it in a straight line, or you can move into a new structure known as cyclo, where it forms either if for cyclopropane, because there are only 3 of the hydrocarbons, and basically what happens is remember what I said for the standard propane, that you have the CH2 in the middle and CH3 at the other end. So both ends of the straight chained propane have the CH3s at the end and the CH2 in the middle. Well, if you go into a cyclo situation where you have a cyclo structure, the atoms on the molecules on the methane molecules on the left and the right ends of the propane chain lose 1 hydrogen atom each. So each of them becomes, the straight chain becomes CH2, 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 and now that forms a triangle, and that becomes cyclopropane. And as you add in more hydrocarbons to things, the cycle stays that way. It stays in a chain there. It always forms. It's a chain of methane formed only with the CH2s. So we can then stretch this out, and if we want to go into go further into this, we are going to come back and go further into this. What we have to do is we're going to look in here we're going to do a skimming through and see because there is more of the cyclo hydrocarbons that we have to go through. But I went through here what I didn't see in here at all in the organic chemistry nomenclature here is I didn't see a mention of hydrocarbons. And what happens is that as I'm reading through here, I wanted to see why there isn't anything on hydrocarbons, and that's because there is a second section for organic chemistry. And when you see here organic chemistry, what it says here is C chemistry. So more likely than not, organic chemistry is treated within organic chemistry, and they say have a second organic compound, C compound. So we're going to go and take a look at those and see what that says. So we're just now finishing up, and we'll take a note on this, that we are finishing up in organic chemistry. Whoa. And we are going to follow this to chemistry. And it says to go to chemistry. And that's what we're going to do. We're going to go to chemistry very quickly. Go to chemistry because our time is almost up. CO CE chemical equation chemistry. And the thing is that we have an enormous amount within chemistry that we have to go through to actually find out where we want to be and what we want to see. So what we're going to do is we're going to leave this for next time because chemistry is such a large section that it's going to take some time to go through. See what happened. This is what they've done here is they've listed in a whole bunch of different areas that are part of chemistry, but rather than treating them all in one section, because things are cross-referenced, we're going to have to sort of jump around in the book here and sort of make our decision as to what is what, because it's not going to necessarily come out and say something specifically. It will infer to different things, because here we're in chemistry here. There's a lot of different compounds. What we're looking for is carbohydrates. They don't, and the thing is, we're doing a quick look here. There is no carbohydrate. What it is, it says cellulose C carbohydrates, right? And so if we look at we want to see sugars and starches. Do they have sugars here? They have soap, C esters, starch, but no sugars. Oh yeah, they have sugars and starch here. C carbohydrates. So what happens is that we end up in what we call a cyclical situation where we go from one situation to the next, and we're going to have to sort of wander around the encyclopedia a little bit to really get our bearings. So we're in that sort of situation there, and then once we've done this and we've done the carbohydrates and the organic chemistry, then we're going to move back to the nucleotides and see how the nucleotides fit in with the rest of the structures here. Alright, so that's it for today. See you in segment 9. Take it easy.